Today on How It's Made. Space pens, for writing fan mail to your favourite stars. Reef aquariums, the beautiful briny in a box. Metal caskets, we promise not to bury you in too much detail. And composite bicycle wheels, we visit the company that pedals them. But first, the space pen can write in zero gravity, which is why astronauts have used it. It also writes underwater, in extreme heat or cold, or when even upside down. All this is possible due to the pen's ingenious design, which allows you to write stuff down even when you're not the right way up. The space pen's ink is pressurized with nitrogen, so unlike ordinary ballpoints, the ink doesn't rely on gravity to get to the tip. Invented in 1966, the pen first went into space with the Apollo 7 astronauts. The pen's writing point starts out as an 8mm long block of stainless steel. It passes through more than a dozen machining operations, which progressively shape a point, then bore a hole through the tip to form a pocket for the carbide steel ball that makes this a ballpoint. The last station inserts the ball and curves the edges of the pocket inward, so that the ball is locked in, but can still rotate to spread the ink. The replaceable ink cartridge begins as an empty brass tube. This assembly machine inserts a white plastic ball into the back end, then pumps in half a gram of ink. The white ball is called the float, and its job is to follow the ink down the tube, moving residual ink forward towards the point. The next machine inserts the writing point into the opposite end of the tube, then crimps the end to ensure it can't dislodge. Back to the other end of the tube, the machine applies a bit of sealant, then injects the nitrogen to pressurize the cartridge, then caps the tube with a hollow brass plug. Nitrogen is ideal for pressurizing. It's an inert gas that doesn't harm the tube or its contents. This demonstration shows how the pressurized nitrogen forces the ink to flow. After subjecting each and every refill to a writing test, the surface is cleaned of any residues, and a printer applies the company name and product information. Certain space pen models have a cap for the pen. A feeder places a brass cap on each spoke of the cap assembly machine, which then pushes the cap into position to receive a clip. The clip is stamped out of spring steel, which is a fairly flexible metal. It's chrome-plated for corrosion resistance and looks. The machine drives the clip's teeth through the wall of the cap, then curls them back towards the inside of the wall, locking the clip in position. To prepare the two-part brass body for the pen, a feeder drops the bottom part, called the barrel, onto each spoke of the barrel assembly machine. To strengthen the writing end, the machine inserts a brass reinforcement piece called the nose tip. It then crimps the end, flaring the nose tip inside the barrel so it won't fall out. This model has a chrome-plated brass body, but a cap minus clip. To begin assembling the pen, workers place the barrel in a foam holder, insert a spring to keep the cartridge in position, then a threaded connector made of brass. The barrel goes through a machine which puts a silicon rubber O-ring on the top edge of the barrel. And now the final assembly. They place a cartridge in the barrel, insert the connector into the top half of the body. Then with an electric motor, thread the parts together. After placing the cap in a foam holder, they insert the pen. The O-ring holds the cap in place. The original space pen still in production has a push button on top to push out the ballpoint, and another on the side to retract it. This demonstration pen has a cutaway section to show the inner workings. All space pen models can write underwater. They also work in freezing cold, intense heat, or even upside down, which is excellent news, because I can now pen me memoirs whilst I'm in the bath, or on the moon for that matter. A reef aquarium takes underwater exploration to a whole new sea level. It's a mini coral reef system recreated in a glass tank. They're incredibly popular and often installed in homes or businesses because a reef aquarium allows people to see life under the sea, you see. A A reef aquarium is a living, breathing and growing ecosystem. Along with tropical fish, it has spectacular coral and more low-profile creatures like crab, shrimp and tiny aquatic organisms. And it's all these organisms that act as a biological filtration system for the water in the tank. They supplement this biological filtration system with mechanical and chemical ones. The assembling technician starts with the pump that recirculates the water. He installs it in an enclosure under the display tank. This is known as the sump. He places a protein skimmer in the sump besides the pump. The job of this unit is to inject air bubbles into the water, removing any organic compounds before they decompose and become waste. He adds a UV sterilizer. It has a high-intensity light that will be activated when needed to kill free-floating bacteria, parasites and algae. Next, he introduces the media reactor. This cylindrical device contains both activated carbon and an aluminium-based media. These materials will absorb fish waste byproducts, thereby removing them from the water. With the mechanical and chemical filters in place, he now moves to the display tank. He spreads genuine ocean sand on the bottom. This sand will be a habitat for some of the bacteria and other organisms that will aid the biological filtering process. He selects some appropriate rocks and transfers them to the aquarium. The rocks are home to numerous algae, bacteria and small invertebrates. This makes them a central part of the aquarium's biological filtering system. He now prepares the ocean potion, adding synthetic sea salt to water. A pump circulates the water as the salt dissolves over a period of 24 hours. He presses a switch and the premix of water and salt flows into the tank. This water now needs to mature. It will take weeks for tiny aquatic creatures to thrive in this water. During this time, the filtering equipment in the sump below helps keep it clean. The protein skimmer foams up as the water constantly circulates through it. After about 3 weeks, there are enough microorganisms in the water and it's ready for its coral and fish. These corals have been grown on an ocean farm and kept in this holding tank for this moment. Each coral is composed of tiny fragile animals called coral polyps. They're a living colony. As the aquarium technician makes his selections, he considers how the coral will adapt to light and water motion, and how compatible the corals will be with one another. Some corals are very territorial and may release toxins when they come into contact with other corals. He leaves space between the corals to give them room to grow. Allowed to thrive, some will triple in size. He now introduces fish. Clearly for them, this aquarium has all the comforts of home. He installs a lighting system overhead that mimics ocean light at different times of the day: sunrise, daytime and sunset. For the creatures in this reef aquarium, light is a source of energy. With the aquarium now complete, the monitoring begins. He'll test the water chemistry regularly to ensure that the right environment is being achieved. The activity of the fish and coral will be under observation to confirm that it's becoming a thriving marine community. Only then will this reef aquarium be ready to go public. So much more than just a fishbowl. The reef aquarium brings the wonders of the ocean to the surface. Now where's that mermaid? Coming up, we see how composite bike wheels are made. It's a bespoke report, you know, according to a spokesman. And we lay to rest your curiosity about metal coffins. See you after the break. A central part of arranging a loved one's funeral is choosing a coffin. This is often an emotionally difficult decision, and it forces us to face the reality of loss. Coffins are most commonly made of either wood or metal, and range in style from understated to ornate. There are two styles of coffins: full couch, models that have an undivided top to show the deceased from head to toe, or perfection cut, that have a split top to show the deceased from only the waist up. This factory makes metal coffins constructed from sheets of steel. To form the top, workers insert a sheet into a press. A die inside draws the metal into a panelled shape. This requires 900 tons of pulling force. After trimming the edges, workers insert the panel into an automated folding machine. Firstly, the machine bends both long sides upward, 2 bends of 90 degrees each. And secondly, it bends both short sides the same way. Then workers weld the corner seams. They also assemble and weld the coffin's sides, ends and reinforced bottom panels. They were also shaped in the press, but with a different type of die, which stamps rather than draws the steel. For a perfection cut coffin, they saw the top in half. Then weld steel to the cut end, forming a header to give it a neatly finished look. An automated belt grinds all the welds flat to create a smooth finish. After cleaning, all the parts travel through a booth, inside which 20 automated spray guns coat them in powder paint. An electrical charge draws the powder particles onto the steel, giving a thorough and even coat, which a giant oven then bakes for 20 minutes. Once the surface cools, workers inspect the paint finish to make sure it's flawless. Workers apply hot melt glue on the inside, along where the bottom and sides meet. This makes the body of the coffin watertight, and they conduct a water test to make sure. The coffin is lined with crepe, a synthetic fabric which is formable when you apply heat. This specially designed machine heats the material with an iron, as serrated wheels gather it into decorative pleats, known as shirring. The high heat forms the fabric to this shape permanently. Sewers cut and sew the sheared fabric into lining components. Meanwhile, workers mount the coffin's steel hardware, either stationary handles or swing bar handles. They place a rubber gasket around the top edge to ensure a proper seal when the top is closed. Then they mount the top. By this point, they've already attached most of the interior fabric over an inner lining of corrugated cardboard. Now it's time to install the steel bed using an expandable rod. The bed height is adjustable, enabling funeral directors to elevate the deceased for easier viewing. A mattress pad and sheet go on top of the bed. Clips on each end hold them in place. A pillow completes the interior. Every coffin undergoes a thorough final inspection. Then it's delivered to the funeral directors. The funeral directors usually carry several sample pieces, showing the range of styles, colours, hardware and fabric options. And no matter what you choose, hopefully, you'll rest in peace. In the cycling world, carbon composite wheels are the wheels of change. They can weigh half the amount of traditional metal wheels, so the cyclist can pick up speed with less effort. But carbon fibre wheels are far more expensive than metal ones, so if you want them, you'll be saddled with the extra cost. Flatter and thinner than metal ones, these high-tech carbon bike wheels are designed to take advantage of carbon fibre's unique characteristics and support the cyclist's weight efficiently. They start by cutting carbon fibre into patterns, and these arcs are for half of a sidewall. The technician layers them onto a band of fiberglass in a mould. The fiberglass will provide a good surface for braking. He drapes a piece of non-stick plastic film over the mould and adds a silicone pressure pad. He stacks several moulds, each with a silicone pad and plastic film. He wraps a heater pad and a plastic vacuum bag around the stack and activates the vacuum. It sucks out the air to pull the melting carbon fibre to the shape of the moulds. He adds an air bladder and a metal plate. This applies more pressure as the carbon fibre solidifies into a sidewall shape. A colleague layers material for the wheel rims by inserting strips of carbon fibre into a long and narrow mould and pushing it into the crevices. He applies strips of carbon to the sides for reinforcement. a resin-based film adhesive is added, followed by more carbon fibre. Using a wedge, he again puts on the pressure, causing the carbon fibre and film adhesive to stick together. He transfers the long layers to a round mould. As with the sidewalls, he heats the rims under pressure to set the shape. He'll get 5 wheel rims out of this one tool. The next technician shapes carbon fibre layers around a metal shaft and flares them out to form the wheel's hub flanges. She smooths the creases and prepares for the vacuum pressure curing by placing a piece of non-stick plastic and a silicone mandrel on top. She stacks the flanges and slides a tube around them. The lid is bolted on. They then go into an autoclave to bake under pressure for about 4 hours. This transforms each patchwork of carbon fibre into a solid, seamless bike wheel flange. Now for wheel assembly. The technician inserts flat carbon fibre spokes into holes in one half of a sidewall. Adhesive and carbon fibre will bond the spokes to the sidewall. A carbon fibre patch is put where the end of the spoke meets the sidewall, and it's taped there. With all the spokes in position, he lowers the lid and applies mechanical pressure. The spokes bond to the sidewall, and it's ready for the rim. With the help of a locating pin, the rim is positioned on the sidewall. He also uses this carbon fibre ring as an alignment tool. He then places the other sidewall half on top. The geometry is precise for maximum strength and resilience. After another compressed bake, he applies adhesive to the ends of the spokes and attaches them to the hub flanges. A metal spacer is put between the 2 flanges for now, and the technician tapes the spokes to prevent adhesive from trickling down onto them during the heating process. He adds a piece of release film and a silicone pressure pad, and then clips metal splints to the carbon fibre spokes to support them through the cure. With the spokes now pressure bonded to the flanges, it's time for fine-tuning. The technician locks the bike wheel in a fixture that lightly stretches the spokes, and this creates the necessary tension and rigidity. Once he's satisfied with the tensioning, he applies resin adhesive through a hole in a hub flange. 2 hours in an oven sets the tensioning, and he removes the wheel from the fixture. After cleaning and the application of graphics, the carbon fibre bike wheel just needs a rubber tyre, and then it's ready for a spin. Hoy, Pendleton, Wiggo, watch out, here I come. Oh, I need a frame.